Before you're told what a semi-Eulerian graph is, but then part A just says a graph, doesn't mention anything about it being simple or semi-Eulerian. So for any kind of graph theory question like this, you just draw it. So 4 vertices, 1, 2, 3, 4, 7 edges, 1, 2, 3, 4, 5, 6, 7, and then count, because it's asking you for the sum of the degrees. So your degree of a vertex is how many edges are going out of that vertex. So 1, 2, 3 here, 1, 2, 3, 4 and 4, and if I add those up, 4, 8, 11, answer's 14. I'm going to do those all in one video. So B, simple, so it's got to have no multiple edges or loops. Semi-Eulerian, exactly 2 of its vertices have to be odd. 5 vertices, 5 edges, exactly 1 has degree 4. So I'll start with the 5 vertices first of all. 1, 2, 3, 4, 5. So I've done that. One of the vertices has degree 4. Let's do that. So 1, 2, 3, 4. Okay, so I've done this bit. 5 edges, so I need one more edge. It has to be simple, so it can't be a multiple edge or loop, and it has to be semi-Eulerian. So if you just look at where you could draw the edge, if I join up there, and that has degree 1, that has degree 1, but these aren't even, so that's done. Okay, see, a semi-Eulerian graph with 5 vertices that's also a tree. So a tree is a connected graph with no loops or cycles. So it's simple, no loops or cycles, semi-Eulerian. So it's just a graph that has to be connected. So 1, 2, 3, 4, 5. So let's just start and draw it. If I connect it all up like this, so it's a tree, then that's got degree 1, but each of these have degree 2. That's got degree 1. It's semi-Eulerian and it's simple. Ticks all the boxes. Done. And the last one. A simple graph has 6 vertices. So 1, 2, 3, 4, 5, 6. The graph has 2 vertices of degree 5. So if I give this one degree 5, 1, 2, 3, 4, 5, that's 1. And then another one degree 5. 1, 2, 3, 4, 5. Explain why the graph can have no vertex of degree 1. Okay. The thing here, it's a 2-mark question, is to explain that if 2 of the vertices have degree 5, then it means that each of those 2 vertices must be connected to each of the other 2 vertices. So there must be 2 edges going into each vertex. But you also need to say that the reason that is happening is because it is simple, because you can't have multiple edges or loops. Okay, because if you were allowed loops, then that wouldn't have to happen. Okay, so just show you what the mark scheme says so I don't have to write it out. So the graph is simple, therefore each vertex of degree 5 must be connected to each other of the 5 vertices. The remaining 4 vertices must each be connected to the 2 vertices of degree 5, so no vertex has degree 1.